There's this hidden, incredibly powerful force that's constantly at work all around us. It's a silent, invisible battle being waged on the very materials that build our world. We're talking the car you drive, the bridges you cross, everything. Today, we're going to pull back the curtain on chemical corrosion. So, let's just jump right in with a big question, right? What is it that's slowly, silently, and just relentlessly eating our world? I mean, this is a process that costs the global economy trillions of dollars every single year. And the culprit? Well, it's not some microscopic creature or a new kind of pest you've never heard of. No, it's something way more fundamental. It's a chemical reaction, a really basic process of nature that causes the stuff we build to break down and, return to a more stable state. All right, so let's get into it. The best way to really think about this process, just imagine it as an ever-present enemy. It's this constant, silent decay that's happening literally all around us all the time. And you have definitely seen the results of this battle before, I guarantee it. Think about those reddish-brown flakes on an old piece of iron. That's rust. Or that kind of dull film that shows up on nice silverware. That's tarnish. These are all just common names for the exact same fundamental process, corrosion. Okay, so if we're going to understand how to fight this enemy, we first have to know exactly what it is, right? We need to put a name to this invisible attacker. So what exactly is chemical corrosion? So here's the scientific breakdown. It's the direct degradation of materials that results from a chemical reaction with its environment. Now, that word direct is absolutely crucial, because this is not the kind of corrosion you're probably thinking of, like on wet, salty roads. This is a straight-up chemical assault, no water needed. See, you're probably most familiar with what's called electrochemical corrosion. That's the indirect attack, the one that needs water to work, the one that makes your car rust in the winter. What we're focused on today, though, is its often overlooked cousin, chemical corrosion, and this is a direct attack. It thrives in dry, gassy, and often super high-temperature environments. Just think about the insane conditions inside a jet engine or a chemical reactor. That's its playground. So how does a direct chemical attack like this actually work? Down on the molecular level. Well, to get that, we need to take a look at the chemistry of destruction itself. All right, time to meet the aggressors. These are the chemical agents leading the charge. The most common one, of course, it's oxygen. But don't sleep on the others. Elements like halogens and sulfur, man, they are also incredibly effective at attacking and breaking down metals when the conditions are just right. Here's a great way to picture this in your head. Just think of the metal being dissolved by its environment, but it's happening molecule by molecule. This isn't some big, sudden, catastrophic failure. Oh no. It's a slow, relentless process where a corrosive gas literally just plucks atoms right off the surface, one by one, and transforms them into a new and usually much weaker compound. The whole attack unfolds in 3 pretty distinct steps. First up, contact. The corrosive gas meets the metal surface. Simple enough. Step 2, reaction. Now this is the critical moment. The atoms on the metal surface literally give up their electrons to the gas. And finally, step 3, formation. That exchange of electrons creates a brand new compound, like an oxide layer, which becomes the physical evidence of the attack. You can actually see it. Okay, so that's the science, right? Down on the tiny microscopic scale. But why does this little battle of atoms and electrons actually matter in our world? Well, because the real-world cost of this chemical war is absolutely staggering. Get ready for this. $2.5 trillion with a T. That is the estimated global cost of all kinds of corrosion damage every single year. I mean, to put that in perspective, that's something like 3 to 4% of the GDP of most industrialized countries. It's just a mind-blowing number that represents failing infrastructure, endless costly repairs, and just lost resources. And this battle, it's being fought everywhere you look. It's weakening the steel in our bridges and buildings. It's degrading the engines in our airplanes and our ships. It's eating away at critical pipelines in huge manufacturing plants. It can even cause the tiny, delicate components inside your phone or computer to fail. The stakes, they are incredibly high. So you see, in the end, this isn't just about things getting old and falling apart. It's much more than that. It's this fundamental, constant struggle between our creations and nature itself, between the things we build and the powerful laws of chemistry.
We engineer these amazing, strong materials, and nature immediately starts working to break them back down. It's a never-ending tug of war.
Which, of course, leaves us with one final crucial question. This battle is constant. The chemical attack is relentless. So, how do we fight back? Well, the answer really lies in understanding this invisible enemy, right? It's why engineers are always developing advanced alloys that are naturally resistant, or creating these incredible, sophisticated coatings that act like shields. The real challenge isn't just to build things, it's to outsmart chemistry itself, finding new ways to win this constant invisible war.